Don't mind me, just making a latte using the power of the fucking sun. One of the key components to me being able to use this domestic coffee machine in my van is an inverter. And that is exactly what we're going to be covering in this episode. So welcome back. If you haven't already, I've made loads of videos on the electrical install of this van. I'm covering all the components that you're going to need to look into, and I'm going to be doing them video by video. So I'm not overloading you all with information in one video. You can just click the video what's relevant to you. So if you want solar panels, click the solar panel video. And this video right now is the inverter video. So the first question, do you need an inverter? Well, you probably won't need an inverter. Many people can get by without an inverter. You don't necessarily need one to do a camper build. But if, like me, you like the finer things in life, you're going to want a coffee machine inside your camper build. But there's other things that you might want to consider once you get an inverter, because it opens up avenues for a lot more things inside your vehicle. For example, I've got a normal domestic fridge in here now, which has saved me a lot of money because the 12 volt fridges, as you're probably aware, are very, very expensive. So the fact that I now have the market open to normal fridges because I've spent the money on an inverter, don't get me wrong, I've probably spent the same amount of money, but I now have a lot more future options in place for the build of my vehicle. Without going off on a little bit of a tangent, but just to delve into that a little bit, is I've spent £150 on a fridge that is a very nice fridge. It's basically a wine fridge. It doesn't go as cold as some of the Dometic ones, but also the Dometic ones are 450 quid often, or any type of brand that is a 12 volt fridge. They're often above £400. And when you consider the amount you'd get in a £400 fridge for a domestic install, you're looking at American fridge freezers. They're massively overpriced, the market's monopolised, which is one of the main reasons why I went down the inverter route. Quite a common thing that I see on forums is people saying, don't get an inverter, they're super inefficient, they're not worth the time. Now let me tell you, parts of these statements are correct, parts of them are not correct. Inverters, the cheap inverters, are super inefficient. When you get inverters, you're looking at modified sine wave or pure sine wave. And without going into the details of it, and it's all about trigonometry and sine waves, you have a pure sine wave, which is where the wave is a nice even curve on the top and the bottom. And it's probably the wave what you're familiar with. Even if you're not into electrical engineering or that sort of stuff, you've probably seen a sine wave at some point in your life. And what that basically means is it starts off at the middle point 0, it'll go up to, for example, 1, it'll go down to 1, and we'll have a nice even curve on the way through that. Now, what are modified sine waves? Modified sine wave is something that is to give the indication that it's going up and down, but it's not quite like that. It goes up 90 degrees across, down 90 degrees across. It's a very uneven sine wave. Modified sine wave can often damage household equipment that uses motors and just sensitive equipment in general. Modified sine waves will work to an extent. You'll probably charge your laptop off one. You'll probably have lots of success with a modified sine wave. There is a market for it. But if you're doing some kind of install where you want the reliability and the efficiency, a pure sine wave is definitely the route what you're going to want to take. A pure sine wave inverter gives power out which is much truer to your domestic install. In some cases, better than the domestic power of your house. So that's when you see that, you're going to see that popping up a lot, modified and pure, and you'll see a massive price difference between the two of them. So don't get caught in the trap thinking you're getting a cheaper inverter when it's actually a different kind of inverter. Another point on pure sine waves is they can often spike. They can spike up to triple the capacity usually. This one, for example, I've got a 2 kilowatt inverter, which is massively overkill, but I built it around this coffee machine. So I got a 2 kilowatt inverter that can spike to 6 kilowatt. It'll often spike to 6 kilowatt for around 30 seconds. However, I've never had my inverter spike. It's just there if I were to ever need it. I might be installing electrical installs in this, such as electrical hobs, induction hobs in the future. Of course, I would have to consider my battery sizes, but without going too much of a tangent on that, I've already got videos about batteries, so we can cover that in the battery video. And as we just alluded to, everyone always bangs on about the efficiency of an inverter. Now, the efficiency of an inverter you'll get in the spec sheet of that particular inverter. Modified sine wave inverters generally have an efficiency of 80%. Pure sine wave inverters generally have an efficiency of 90 to 98%. You'll never get one that's 100. The issue is when you're inverting or transforming power, you're always going to lose some power. It's not free to transform power. So you're always going to lose an element of that. So if you have an inverter that has an efficiency of 90%, for example, if you pump 1 kilowatt into that inverter, you're only going to be getting 900 watts out of it. So you're going to be losing 100 watts. And that's over an hour period. So if you're using that for what I just did, 30 seconds to make my coffee, I've lost 10% over 30 seconds, which is not much. When people see that on paper and they think, oh, 80% efficiency, that's going to kill my batteries. You're not using it all the time, so don't get too hung up on the efficiency of it. So next, you're going to be wondering, what size inverter do you need? There's loads of sizes. Some of them are going to be rated in watts, all the way up to a kilowatt, 2 kilowatt, 3 kilowatts. Make sure you're buying it sold on the rating that it can give out normally, not the rating that it is spike output, because they'll often sell them as that. So you might think you're buying a 6 kilowatt inverter, which by the way is massively overkill for this, but it's a 6 kilowatt spike inverter. Like I said previously, it can only do that for around 30 seconds. But that's the way that some of these cheaper inverters get around selling you an inverter that you think is fit for purpose. And for example, that on a smaller scale, you might have a 900 watt inverter that's actually a spike inverter. So normally it's going to be giving out 300 watts until you need it for that 30 seconds. If you tried using it for longer than that 30 seconds at 900 watts, it will probably have an internal trip that will just trip it out and not let you use it until it cools down. So there's ways you can work out exactly what inverter you need. And what I did is I knew I wanted a coffee machine, so I went to like Curry's or just a normal appliance shop, and I was looking at the base of coffee machines. And when you look at coffee machines, you're going to have like an information plate, or any appliance, you're going to have an information plate. Generally that's going to give you the voltage, either the wattage or the current. Now if it doesn't give you the wattage, you can work out the wattage using the voltage of the current. And without getting too technical, there's a power triangle. And basically what that is, I'll put it up on screen now, it's P over I and V. If you're not familiar with how these triangles work, what it means is your P is your power, which is your wattage, your I, which is your current, and the V is your voltage. Now we can fill in the voltage because we know we're at 230, 240 volts. So you can just put that figure in there. Now if we've got our current, which for example is 10 amps, we'll put 10 amps in the current section. When we timed the current by the voltage, which in this case is 10 times 230, that's going to give us 2,300 watts. So if you had something that had 10 amps, you would need to get an inverter that is rated at 2,300 watts. One thing to consider when looking at these plates though, they are the maximum permitted current for that appliance. Quite often they won't do that, they'll only do that in bad situations. Although you need to prepare for it to do that, often it's not going to be drawing that amount of current. So don't think, oh, we're on 2,300 watts, that's going to kill my batteries. You might make a coffee like I just did and it only went up to 900 watts, even though this is rated at 1300 watts. And like I say, that's over an hour period. So this giving out 900 watts for the 30 seconds I just used it, barely made a dent in my batteries. And now I've shown you the power triangle, you can go give people advice on forums because you're an electrician. So now you've decided what size inverter you want and the type of inverter you're going for. Your next question is, how am I going to wire it? Now there's an easy answer to this, and unfortunately I'm not the man to answer it for you. You need to check the wiring specifications of your particular inverter. However, if you have an inverter that requires a certain cable size, you can go up in cable size, but you can't go down. Don't think, oh, I'm only going to be using 1 kilowatt of that inverter so I can drop it down a cable size. Just wire it to the manufacturer's specifications. And also, try and put any fuses or breakers towards the start of the line. So if you're coming from your batteries to your inverter, your fuse wants to be as close to your batteries as you can possibly get it. Obviously you don't need to have it on your battery so it's awkward to work on, but you definitely want to have a little leg coming off that battery, then your fuse and then your inverter. And of course you'll rate your fuse according to the manufacturer's specifications again. Another thing to consider is placement of the inverter. Inverters often need air cooling. So if like me you've put it in a little, my inverter's hidden down here in a little cubby hole. I'll try and get a picture and put it up on the screen now. It's very, very tight in here. I knew that was going to potentially cause an issue later on down the line with cooling of the inverter. I'm fully prepared to install fans into that box so I can have airflow going through the back of my units here. But for now it seems to be working perfectly fine. If I'm being honest, that fan barely ever spools up because I never use the inverter for long enough. If it's just powering my fridge, the fan doesn't require to spool up because the fridge is not taking that much power. If I were to bang this on for probably 5 minutes straight, the inverter would probably need to start cooling itself. But that's an issue I'm going to attack if that ever presents as a problem. Also, this might not be advised by the manufacturer, but put your inverter on an isolator. I went for an inverter that had a power saver mode, so basically that means when nothing's on there it completely isolates itself, or literally isolates itself to where the power draw is just the screen being lit up. So there's not much power draw at all. And even I put an isolator on that, so when I'm not using it I can just completely isolate it from the circuit, I'm not losing any power, and it just gives me that peace of mind that when it's not in use it's not drawing power and I'm not going to flatten my batteries. Another thing to consider when pricing up your inverter is they can often come with additional features. So some of them can have MPPT charge controllers, some of them can have battery charge. So you might think that this inverter at £450 is very expensive, but you're not going to have to buy a battery charger because it's already got it installed in it. One thing to consider though, without going too much into the batteries because we've got a video for that, is that make sure your inverter charges the batteries what you have. So for example, my inverter won't charge lithium batteries. So if you have lithium batteries, you're going to have to get a specific charger for the lithium batteries. But that's not the end of the world, because I don't need to use that battery charger. So if I did ever get lithium batteries, I could just buy an additional lithium battery charger and install that into my engine room as such back here. And finally, just to recap on something I said earlier, one of my biggest bugbears about inverters in vehicles, and I see professional companies doing this, as we previously mentioned, it's inefficient to invert or transform voltages because you lose some of that power on that process. So if you have an inverter and you're transforming your 12 volts up to 240 volts, don't fit a socket with a USB socket in, because that's just inefficient. Again, you're stepping it back down to 5 volts. You're better off getting the 5 volts from your 12 volt batteries and just having a separate one, like I've got under here, just a separate, oh, you can't see it on the camera, like I've got here, just a separate 12 volt thing that comes straight from my batteries. I've basically got two rings in here. I've got my 12 volt ring and I've got my 240 volt ring. Now they're not ring mains, so any electricians out there, they're not actually rings, I'm just using that as a term. But yeah, it's really inefficient to go up, down, up. You don't want to do that, or down, up, down. Just try and invert it as little as you possibly can, or transform it as little as you possibly can. Hopefully I've given you enough information there to go away and purchase an inverter and not be worried, and don't be put off by the people on the forums that have built their own van in their Transporter T4 that are going to give you advice because they did theirs once 5 years ago. Inverters are great, inverters are fantastic. Many modern houses are running off inverters because they're coming off these solar panel grids. Inverters are the future, so don't be worried about putting one inside your vehicle. It makes so much sense. But like I say, you definitely don't need one. If you don't want the luxuries of a coffee machine or nice appliances, which many people don't, some people might think this is a stupid idea, then you absolutely don't need one. And do your 12 volt install and make it super efficient because you're not changing the voltage. If you have any questions, please do drop them below. And just on a side note, a massive thank you to the support I've been getting. I never expected this channel to pick up this quick. I've been getting messages from people complimenting me on my video delivery, on the knowledge, and it just feels so good because when you're editing yourself and you're watching videos of yourself, you're always critiquing yourself, so it's nice to get that feedback from people. I'm just about to touch 1,500 subscribers, which is insane for the amount of time I've been on here. So again, thank you very much for all the support you've all been offering.